Hi, this video is here to help you with drawing lines and angles accurately. Let's start by recapping how to measure a line accurately. To measure this blue line correctly, the 0 on the ruler has been placed on the end of the line. Each small interval on the scale is equal to 1 millimetre. There are 10 millimetres in 1 centimetre. This line is equal to 70 millimetres or 7 centimetres. In this example, the red line is equal to 85 millimetres, 8.5 centimetres, or 8 centimetres and 5 millimetres. The 0 of the ruler has been lined up to the end of the red line. Now it's your turn. Once the line has been drawn between these two dots on the screen, use the ruler to identify the closest measurement of the line. Try to be as accurate as you can whilst reading the intervals on the ruler. You can pause the video once the line has been drawn to work out your answer. All finished? Well done, here's the answer. The line measures 12.5 centimetres. The line has been measured correctly as the 0 of the ruler has been lined up accurately with the end of the line. Have a look at these two lines. Line B is 3.2 centimetres longer than line A. We know this because the red line, line B, stretches out to 13.2 centimetres, whereas the blue line, line A, stops at 10 centimetres. Let's move on. Here are 3 lines. Can you estimate which line is the longest and which is the shortest? Let's have a closer look. Line A is 12 centimetres. Line B is 8.8 centimetres. Line C is 15 centimetres. That's right, line C is the longest and line B is the shortest. You may notice that our ruler also shows these measurements in millimetres if we read the other side of the numbers. So, for example, we could say that line C measures 150 millimetres because there are 10 millimetres in 1 centimetre. The lines are redrawn and changed slightly. Can you match the lines described with the image? Line A is 12 centimetres. Can you find the line which is 25 millimetres longer than line A? Line B is 8.8 centimetres. Can you find the line which is 1.5 centimetres shorter than line B? Line C is 150 millimetres. Can you find the line which is 2 centimetres longer than line C? Pause the video now whilst you work out your answers. Great job! Here are your answers. The green line is 1.5 centimetres shorter than line B. It's 7.3 centimetres. The pink line is 25 millimetres longer than line A. It's 155 millimetres. The purple line is 2 centimetres longer than line C. It's 17 centimetres or 170 millimetres. Let's see how we might be able to apply this skill to drawing angles accurately. Here is another line of 7 centimetres. To add an angle of 30 degrees to this line, we'll need to use a protractor. First, we need to place the protractor at one end of the line, taking care to line up the 0 and centre point or origin of the protractor carefully. Next, we need to use the scale on the protractor to measure an angle of 30 degrees. There are 2 possibilities on the protractor. Remember, an angle of 30 degrees is an acute angle, so it should look like it's less than 90 degrees. Try and imagine this in your head. If we want to draw an angle of 30 degrees, we will need to use the outer scale, which starts at 0 to make sure it's an acute angle. Mark a dot on the exact position of the angle required. Finally, remove the protractor and use a ruler to join the dot back to the original straight line. Check the angle looks correct, or use your protractor to remeasure. Here we were drawing an angle of 30 degrees, which is an acute angle and is less than 90 degrees. Now it's your turn. Can you decide where you might add the dot to draw these angles? Remember to read from 0 on the protractor each time. Pause the video now while you work out the answers. All complete! Well done, here are your answers. To mark an angle of 55 degrees on this line, we need to read the protractor round from the right hand side to 55 degrees. 55 degrees is halfway between the two labelled intervals, 50 degrees and 60 degrees. To mark an angle of 115 degrees on this line, we need to read the protractor round from the left hand side to 115 degrees. 115 degrees is halfway between the two labelled intervals 110 degrees and 120 degrees. And now we can use our ruler to join the dot back to the original line. We're now going to draw an angle of 60 degrees using two lines of 9 cm and 7 cm. To draw the angle of 60 degrees accurately, we need to use a protractor. Place the origin or centre point of the protractor carefully at one end of the line. To draw an angle of 60 degrees, there are two possibilities. Both the green and red dots appear to show 60 degrees. Remember that 60 degrees is an acute angle, which is less than 90 degrees. Try to imagine what an acute angle looks like. Which line, green or red, looks correct? That's right, the green line shows an angle of 60 degrees. We've used the inner scale of the protractor, reading from 0, which is lined up with our baseline. Finally, we need to draw the second line of 7 cm, using a pencil and ruler. Be careful to draw the line from the 0 on the ruler. So here we have our finished lines and angle. Our baseline measures 9 cm, our second line measures 7 cm, and our angle measures 60 degrees. Remember to always check your work once you finish to check for accuracy. For our final challenge, let's see if we can apply our learning to a question involving both lines and angles. Emily is describing a shape. My shape has 4 sides. My shape has 2 right angles, 1 obtuse angle and 1 acute angle. What could my shape look like? Pause the video now whilst you try to draw the shape that Emily is describing. Have you decided what shape it might look like? Well done. There are several possible answers. Here are some ideas. There may be other different ways that you could also draw this shape. Try to check that your drawing has 4 sides, 2 right angles, which each equal to 90 degrees, 1 obtuse angle, which is an angle more than 90 degrees but less than 180 degrees, and 1 acute angle, an angle that's less than 90 degrees. I hope this video has helped you to draw lines and angles accurately. If you're looking for more maths help, then we've got lots more videos just like this one over on the Twinkl website. So go and check them out.